So if the velocity is linearly increasing or decreasing, just like in the case जो मैंने यहाँ पे ग्राफ के अंदर बना रखा हुआ है, तो यहाँ पे the velocity is linearly increasing. तो यहाँ पे अगर मुझे एवरेज लेना होगा, I'll just take the average the way we take average of anything. Like we add two things and we divide them by the number that is two because they were two objects. Same goes if the velocity was linearly decreasing. तब भी यहाँ पर ऐसा दो velocities को हम ऐड करते हैं, initial and final velocities को, and divide कर देते by two. But if the velocity is constant, for example, या फिर other than linear, like this, तो वहां पे we have different method. तो उस चीज को there is only one question, there is only one MCQs of such type. तो जब हम उस MCQs पर पहुंचे, उस MCQ पर पहुंचेंगे, तो I'll be discussing that method over there. ठीक है. Mostly you have to remember that average velocity examiner would be asking for average velocity only in the case of linearly increasing or decreasing velocities, right? Now, coming back to the question that we were discussing of average speed, just to recall that how technical the examiner could be in asking the question. There was a situation that a plane that moves from point A to point B, it travels a journey from A to B, not necessarily in the straight line. I just drew a straight line, not necessarily in the straight line. It travels from A to B with an average speed of 600 kilometers per hour, and it returns with on the same path from B to A with an average speed of 400 kilometers per hour. Now the examiner asked find out the average speed for the total journey. Average speed for total entire journey. That includes moving from A to B and then B to again A. Now, any random guesses what it could be and how it could be done?
I thought it was 100, but because
Sorry, I didn't.
because I thought it was 100 because 600 plus and then minus 400 because it's in the opposite direction divided by 2.
Okay. Since we're talking about average speed, that's a scalar quantity, and we are talking about distance. Again, that's a scalar quantity. So we cannot take minus sign over here, right? So it's simple yet complicated. Actually, the formula for average speed is total distance over total time, right? Now let's consider the distance from A to B and B to A was similar, as it said, because the question says it takes the same path, so distance is same. So the total distance becomes 2D. Am I right?
Yeah.
Okay. Now since it's covering similar distance with similar speed, when it was moving from A to B, the speed was 600 kilometers per hour, and from B to A, the speed was 400 kilometers per hour. So it's obvious that there would be the plane would have covered the two distance in two different times because of the two different speeds, right? So I cannot say that the time from A to B and time from B to A is equal. So I just name them T1 and T2. So if I'm finding out the average speed, so it would be total distance over total time. So this is how it can be written. Now, what about the total time? What about the time T1 and T2? So let's find out T1 and T2 first. If I talk about T1, so T, according to the basic formula, it should be uh, distance over the speed. So similarly, T1 could be written as the distance was D, but the speed was 600. And for T2, the returning journey, distance was same D, and the speed was 400. So I got two values of T1 and T2 in terms of D, which I can replace in the formula which we wrote earlier. So I can say that 2D equals to D upon 600 plus D over 400. Now this over here is T1, this over here is T2, and this is the total time. So total distance divided by total time, we have got this. Finally, what I can do is I can simply take D as a common factor out, And I can even cancel out d from the numerator and denominator. But I'm left with 2 divided by 1 over 600 plus 1 over 500. Now this is something calculatable. So when you put these values in the calculator, you'll get a value which is 480 kilometers per hour. So this is basically the average speed by which the plane covered the total distance from A to B and B to A. So it was a very simple concept, but a very complicated question, right? So examiner could be a bit tricky in such concepts. I hope you got the question, right?
Yeah.
Okay. So we'll practice it more further. Let's move on towards the most important physical quantity, that is acceleration. We'll be discussing acceleration throughout the chapter and even further than in other chapters also. Now, technically, we define acceleration as a rate of change in the velocity, right? हम लोगों ने इसको बचपन में भी पढ़ा. इसका formula we do it as uh, generally I can write as del v over del t. Del v is the change in velocity, and specifically I can write this v minus u upon t, where v is my final velocity, u is my initial velocity, and t is the time taken. Since it involves change in velocity, so it is referred as a vector quantity. मतलब direction would be involved over here, right? And it's measured in units, that is meter per second square. Now, most amazing things about acceleration that we'll be discussing over here, that acceleration is the change, right? The change in velocity. Now, a change, how a change could be noticed, measured, or anything, what a change would be referred as. If the velocity increases, that is a change. If a velocity decreases, that is again a change in velocity. But what if I say, okay, what if the magnitude of velocity remains constant, remains same, but its direction changes? So is it a change in velocity? If just there is a change in, even a slight change in direction, but there is a change in direction, the magnitude is still the same. So would the velocity be referred as a changed velocity?
Yeah.
Yeah.
Velocity is changing.
So since it's a vector quantity, even if the direction changes, the velocity changes. It means even if the velocity, even if the direction changes, but the magnitude remains same, we'll say that object is accelerating. So acceleration does not only mean that there would be an increase in velocity. A decrease in velocity is also an acceleration, right? A change in direction is also an acceleration. Now, uh, if we specifically talk about as a change in direction, we won't be talking much about change in direction in our AS level. We'll be discussing this factor in our A2 level. There's a chapter, a specific chapter for this circular motion. बहुत डिटेल में डिस्कस होगा ये वाला फैक्टर. फिलहाल अच्छा फिलहाल एक चीज वो ये कि if the velocity is increasing, if the velocity is increasing, acceleration is positive, but only referred as acceleration. We never say positive acceleration, right? If the velocity, if the velocity is decreasing, acceleration mathematically is negative. ऐसा है? And we named it, we have a specific name for this. We referred it as deceleration. or retardation is one of the name, an obsolete name from our syllabus. We usually refer it as deceleration, right? In O levels, deceleration was often referred as negative acceleration. But over here, negative acceleration being negative does not always mean it is the velocity is decreasing. ये एक बड़ी स्ट्रेन सी नेगेटिव एक्सेलरेशन होगा, बट हमेशा नेगेटिव एक्सेलरेशन का मतलब जो है वो डिक्रीज इन वेलोसिटी नहीं होगा. देखिए, द एक्सेलरेशन हैज इट्स डायरेक्शन एंड द डायरेक्शन ऑफ एक्सेलरेशन इज सेम एज द डायरेक्शन ऑफ द रिजल्टेंट फोर्स. बेसिकली हम लोग फोर्सेस नहीं पढ़े, लेकिन थोड़ा बहुत तस्करा यहाँ पे करना होगा, थोड़ा बहुत उसकी डिस्कशन करनी होगी, राइट? फोर्सेस के बगैर एक्सेलरेशन को समझना थोड़ा सा मुश्किल होता है. Acceleration is always caused by an unbalanced force. And whatever the direction of an unbalanced force is, that is the direction of the acceleration. So let's say if the acceleration has, yeah, the unbalanced force has a negative direction. So the acceleration would also have a negative direction. But negative direction होने की वजह से is the object, is the velocity of the object increasing or decreasing? ये जरूरी नहीं है कि हर दफा ऐसे ही हो. ठीक है. ओलिवस में हमने ऐसे केसेस पढ़े थे जहां पर नेगेटिव एक्सेलरेशन वाज ऑलवेज अ डिक्रीज इन वेलोसिटी, बट यहां पर ऐसा नहीं हो. ठीक है. तो इस बात को बहुत डिटेल में समझेंगे, इस पे अभी परेशान नहीं होगा, लेकिन लिख लेते हैं.
Can we say negative acceleration is just acceleration in the opposite direction?
Yes, exactly. We can say that negative acceleration is always the acceleration in the opposite direction, which sometimes may cause a decrease in velocity and sometimes it may cause an increase in velocity. How it may cause an increase in velocity, ये देखना है बस. ठीक है. सो सबसे पहली चीज जो हम लोगों ने यहाँ पे हाईलाइट करनी है, तो वो पॉइंट में लिख लूँ यहाँ पे कि नेगेटिव एक्सेलरेशन. आई होप ये पॉइंट आप मेरे साथ साथ लिखते होंगे. नेगेटिव एक्सेलरेशन इज नॉट ऑलवेज a deceleration. ठीक है. Negative sign indicates the direction of the resultant force. Now, these things, positive, negative signs, and all this, जो कि अभी हमने discuss किया, even if we understand it very thoroughly, बहुत अच्छे से, they might create some sort of confusion in the beginning. तो उससे भी ये आपने परेशान होना, it's totally common. ठीक है, to get confused in this, and definitely the practice would, you know, make it clear. Now, we have four situations जहाँ पे हम इस चीज को समझेंगे, and फिर हमें actually realize होगा कि हमें कैसे पता चलेगा कि when would the velocity increase or decrease, right? The first example, let's say कि this is an object, right? And it is moving in a forward direction. ठीक है. Forward direction जिसको हम right hand side मतलब positive consider कर रहे हैं. Now this object is being acted upon by any unbalanced force, any resultant force, which is again in the direction of the velocity, that is in the positive direction. Since the force is in the positive direction, the acceleration would also have the same direction, that is positive. Now, अगर मैं डायरेक्शन के पॉइंट ऑफ व्यू से बात करूं तो आई रेफर दैट वेलोसिटी हैव अ पॉजिटिव मैग्नीट्यूड, the acceleration has a positive magnitude, the resultant force still have a positive magnitude. Now let's comment upon the magnitude of the velocity. Would it increase or decrease? यहाँ पर velocity would increase. How? Now imagine going in a specific direction and being pushed in the same direction. I was moving forward and someone pushed me in the same direction I was already moving. So definitely my velocity would increase. If a ball is rolling towards right and you kick it further towards right, so it will move with an increased velocity now because the force was in the direction of the velocity itself. So the object accelerated in the same direction. So if the object is accelerating in the same direction as the direction of the velocity, it means the velocity would increase. Now, second example, अगर मैं यहाँ पे लूँ, so for example, if we have the same object moving in the same direction, that is in the positive direction towards the right hand side, but now acted upon by any unbalanced force which was acting towards the left hand side. And how could it possibly happen? If I'm moving in a forward direction and I'm being acted upon by air resistance force in the backward direction, तो मेरी velocity आगे की तरफ हो गई, मेरी जो air resistance लग रहा है वो पीछे की तरफ हो गया, opposite direction हो गया. Acceleration now would have the same direction, which is the direction of the force, negative. तो यहाँ पे directions की अगर बात करें तो velocity is still positive, but the force over here, since it's negative due to direction only, the acceleration will also be negative due to direction only. What about the velocity of the object? Will it increase or decrease?
It's increasing.
The velocity is increasing. If I'm moving in the forward direction and something or someone is pushing me in a backward direction, so don't you think I would have a decrease in my motion?
Yeah, velocity will decrease.
Think clearly. If I am moving, let's say I am running towards a seashore. Okay. I was running in the air and I entered the water. The water would exert a resistive force which must be greater than the resistive force air was exerting on me. So would my motion be the same, or I would decrease, or there would be a decrease in my velocity? I would slow down a bit, right? Why I slowed down? Because the velocity was in the opposite direction. I was moving in the forward direction, and there's a force which is pushing me backward, which is uh, stopping me or slowing me down. So yeah. So in this case, the velocity is decreasing. So the velocity would decrease.
But wouldn't we like the velocity of the object is towards the right hand side, right? So shouldn't the acceleration also be towards the right hand side?
No,
But since there's an opposite force, it's going to have there's going to be less acceleration in
acceleration
this.
solely depends upon the resultant force. Whatever the direction of the force is, that would be the direction of the acceleration. We're talking about the resultant force, so we are talking about the resultant acceleration. Let's say if I am moving in a forward direction and I was exerting a force in a forward direction, right? मैं आगे की तरफ एक force भी लगा रहा हूँ. So definitely there would be an acceleration due to that particular force in a forward direction. But a larger force was pushing me backwards. So I won't be acted upon by two different forces. मेरे ऊपर एक ही force लग रही होगी. That would be the resultant of the two of the forces acting upon me. One in a forward direction and in a backward direction. Let's say the force that was acting in a backward direction had a greater magnitude. Now the resultant force would be acting in a backward direction. Hence, the resultant acceleration, there would be only one single value of the acceleration, that is due to the resultant force. Since the resultant force is acting in the backward direction, the resultant acceleration is also in the backward direction. So my velocity would decrease. Getting the point?
Yeah, but acceleration still wouldn't be towards the other side.
Acceleration would still be in
The same direction as the velocity.
acceleration would be in the direction of the resultant force. Okay. We did this thing. Actually, you might have done this in your O levels. Remember this?
Yeah.
Now, this is the resultant force, which says that in whichever direction of the resultant force is, the acceleration would have the same direction, right? Now, negative acceleration means that there's a decrease in the velocity, right? In this case. Now, where would be the velocity same, negative and increasing? ये चीज अभी देखते हैं. बस एक चीज आपने ध्यान में बिठानी है कि the acceleration की जो direction है ना, it does not depend upon the direction of the velocity. It never depends upon the direction of the velocity. Actually, अच्छा, one thing जो कि आपके दिमाग को शायद थोड़ा सा ट्रबल कर रही है. We are referring it as acceleration. सो देर इज अ चांस कि आपको जहन में वही पॉजिटिव एक्सेलरेशन आ गया, राइट?
Yeah.
अच्छा, नाउ वी आर टॉकिंग एक्सेलरेशन, वी आर टेकिंग एक्सेलरेशन एज अ वाइडर टर्म। एक्सेलरेशन जिसके अंदर डिसेलरेशन भी हो सकती है इफ इट्स इन द ऑपोजिट डायरेक्शन, एंड इफ इट्स इन द सेम डायरेक्शन तो इट्स acceleration, it's positive acceleration, right? So we are talking, we are taking acceleration as a wider term, we are taking acceleration as a change in velocity. तो यहाँ पे acceleration का मतलब है कि there is a negative change in velocity because the direction of the resultant force is opposite. Make sense?
Okay, yeah.
Okay, चले। अच्छा, अब दूसरी एग्जाम्पल, द पॉइंट इज के ओ लेवल्स के अंदर वी जस्ट कवर्ड दीज टू सिचुएशन। तो तभी हम हमेशा नेगेटिव एक्सेलरेशन को डीसेलरेशन कह दिया करते थे, एंड विच इज ट्रू ओवर हियर इन दिस केस, इट इज वेरी मच ट्रू। द एक्सेलरेशन इज नेगेटिव, यस, the velocity is decreasing, yes, so the object is decelerating, so we can say that negative acceleration is deceleration in this case only. But what about, let's say, the third case? Now in the third case, the object is moving in a backward direction. Object is moving in a backward direction, and there is a resultant force is still in the backward direction. Hence, the acceleration would also be in the backward direction. Since the backward direction is considered to be negative, so according to these situation, the velocity of this object would be negative due to direction. The resultant force would be negative again due to direction. The resultant acceleration would also be negative. But what about the magnitude of the velocity? Would it increase or decrease? In this case, velocity would increase. Although, although, although the acceleration is negative. So basically, the catching point, the punchline is, if the velocity and the resultant force are in the same direction, the velocity would increase. If the velocity and acceleration or resultant force are in the opposite direction, the velocity would decrease. यहाँ पर velocity was negative, but the resultant force was also negative. The negative sign indicates that तो तुम किस direction में कर रही है? If I am in a car and I am reversing my car, तो reverse करने के लिए भी मुझे उसको accelerate तो करना होगा ना? अब वो जब मैं accelerate करूंगा तो where would be the engine putting the force in the backward direction? तो where would be the increase in velocity in the backward direction, right? तो ये जो backward direction है ये negative है। तो यहाँ पे वो केस आता है कि the acceleration is negative according to the direction, but it's not a deceleration because velocity, force, and acceleration were having the same direction. So the key point, the punchline is, if the velocity and the resultant force are in the same direction, या फिर velocity and the acceleration are in the same direction, velocity increase हो रही है। और अगर velocity and the acceleration are in the opposite direction, तो इसका मतलब है कि velocity decrease हो रही है। अगर इसको थोड़ा सा कॉमन सेंस के साथ सोचें, वो ये कि अगर मैं आगे जा रहा हूँ कोई मुझे आगे ही पुश कर दे, I would rather fall. Why? Because my velocity suddenly increased, right? But if I move
Yeah.
in the forward direction and someone tries to push me backwards, so that would slow me down or stops me probably depending upon the direction, magnitude of the force. The reason is the force resisted the motion. It actually it was a resistive force, ठीक है ना? And in this case, sorry, in this case or in this case, the force was actually supporting the motion. जिस डायरेक्शन में जा रहा था ना ऑब्जेक्ट, उसी डायरेक्शन में फोर्स लग रही थी, तो देयर वाज एन इंक्रीज इन वेलोसिटी। लास्ट केस देखते हैं ताकि कंपैरिजन और आसान हो जाए। लास्ट केस में, दिस इज द लास्ट केस जो हम लोग डिस्कस कर रहे हैं, ऊपर वाला केस भी सामने रहे ताकि कंपैरिजन आसानी हो जाए। द ऑब्जेक्ट इज मूविंग नाउ इन अ बैकवर्ड डायरेक्शन, but there is a resistive force or any force which is acting in a forward direction. And since the force is in a forward direction, तो acceleration भी forward direction में होगी। तो यहाँ पे I would say that velocity is negative, right? Acceleration is positive. right? Force is positive. What about the magnitude of the velocity? Velocity would decrease. Velocity would decrease. रीजन क्या है? रीजन ये है कि फोर्स और वेलोसिटी अलग अलग डायरेक्शन में, ऑपोजिट डायरेक्शन में कर रहे हैं. आई एम रनिंग बैकवर्ड एंड समवन इज पुशिंग मी इन अ फॉरवर्ड डायरेक्शन, डेफिनेटली आई वुड स्लो डाउन, राइट? वही पानी वाली एग्जांपल ले ली, मैं उसमें उल्टा भागता हुआ जा रहा था, पानी ने मुझे आगे की तरफ फोर्स लगा दिया, राइट? तो मेरा मोशन जो हो जाएगा वो डिक्रीज हो जाएगा, माय वेलोसिटी वो डिक्रीज. सो व्हेन डज द वेलोसिटी इंक्रीज? ठीक है, वेलोसिटी इंक्रीजेस. जो जो हमने यहाँ से की फैक्टर्स लेने हैं वो ये है कि इफ, ये बात हमने लिखी थी, नहीं लिखी, चलो हम इसको लिख लेते हैं. हमने लिखा कि इफ the velocity and the resultant force, अगर resultant force है तो डेफिनेटली एक्सेलरेशन भी उसी डायरेक्शन में होगी, आर इन सेम डायरेक्शन. अच्छा, अब सेम डायरेक्शन से मुराद ये है कि भाई कुड बी सेम डायरेक्शन इन पॉजिटिव, कुड बी सेम डायरेक्शन इन नेगेटिव, ठीक है ना? तो अगर ऐसा होता है velocity would increase, ठीक है ना? Because the will force is supporting the motion right now. And second point, if the velocity and the resultant force as an acceleration, क्योंकि same direction होगी, are in opposite direction. अब opposite ऐसे भी हो सकते हैं कि velocity positive, force negative, या force positive, velocity negative. Opposite direction, the velocity would increase, sorry, decrease.
I had a question. Wouldn't the wouldn't velocity be a result of the resultant force if like the resultant force on an object is acting towards the right, then the object will move towards the right. Hence it will be the
अच्छा,
velocity will be towards the right.
actually, when we say that velocity is in the direction, for example, that totally depends upon where we started. Let's say, if the object was initially at rest and then the force was there, then definitely uh, the velocity and the force would be have the same direction. But right now we are saying that the motion of the object, as in the velocity of the object, was already there. For example, I was moving, ठीक है, and air resistance started to act upon, right? या फिर I was moving in a backward direction and air resistance started to act in the opposite direction, right? बिल्कुल इसी तरह, like for example, you did this in your O levels. When we say that there was a parachutist which was falling and its velocity was downwards, and all of a sudden the parachutist decides to open up the parachute. Now, as soon as he opens up the parachute, a tremendous amount of resistive force acted upon it in the opposite direction. So the air resistance. So the velocity would still be in a forward direction. Object तो फिर भी नीचे ही गिरेगा ना आपके पास. But the resultant force due to the opening of the parachute, it decreased the motion. ठीक है? अच्छा, when we say the motion of an object, actually we are talking about an object which is already in a motion, right? Motion as in movement. And if we have to decode the term motion, तो replace it with the term velocity. If I say an object already in a motion, it means object that already had a velocity. Object with a uniform motion, it means object that was moving with a uniform velocity. If I say decreasing motion, object which had its velocity decreasing, and similarly increasing motion as in increase in velocity. सो यहाँ पे जितने भी चार केसेस हमने पढ़े ना, वी आर एक्चुअली टॉकिंग अबाउट कि मोशन ऑफ एन ऑब्जेक्ट, मतलब ऑब्जेक्ट की डायरेक्शन ऑफ ट्रैवल क्या है, ऑब्जेक्ट कहाँ एक्ट कर रहा है. हाँ, इफ वी स्टार्ट फ्रॉम रेस्ट, राइट, तो इन दैट केस जैसे हमने ये वाली चीज डिस्कस की थी, ये लेट्स से कि पहले मैंने फोर्स लगाई एंड द ऑब्जेक्ट मूव्ड इन द सेम डायरेक्शन. लेकिन ये वाला कौन सा केस है कि ऑब्जेक्ट इज मूविंग इन अ फॉरवर्ड डायरेक्शन बट द रिजल्टेंट फोर्स सडनली इन अ बैकवर्ड डायरेक्शन. आई वाज मूविंग इन अ कार, मेरी गाड़ी आगे की तरफ जा रही थी एंड आई अप्लाइड सम ब्रेक. अब मैं ब्रेक लगा रहा हूं, द ब्रेकिंग फोर्स इज इन द ऑपोजिट डायरेक्शन. डज इट मीन्स कि मेरी गाड़ी बैकवर्ड जाना शुरू हो जाएगी? नहीं, माय कार वुड नेवर ट्रैवल बैकवर्ड. ठीक है, इसका मतलब ये है कि द वेलोसिटी इज डिक्रीजिंग. सिमिलरली इफ आई वाज मूविंग इन अ बैकवर्ड डायरेक्शन, मैं गाड़ी को रिवर्स कर रहा था, लेकिन रिवर्स करते हुए भी तो ब्रेक लगाते हैं ना बाद में. तो जब मैं गाड़ी को रिवर्स करके अब ब्रेक लगाऊंगा, तो अब ब्रेकिंग फोर्स वुड बी इन अ फॉरवर्ड डायरेक्शन ऑपोजिट टू द डायरेक्शन ऑफ द मोशन. तो द एक्सेलरेशन इज आल्सो इन अ फॉरवर्ड डायरेक्शन ऑपोजिट टू द वेलोसिटी, ऑपोजिट टू द डायरेक्शन ऑफ द मोशन है. सो वहां पर इट वुड डिक्रीज. लेट्स से assume for a second, if the velocity would always be in the direction of the force, तो फिर यूनिवर्स में कोई ऑब्जेक्ट रुकता ही नहीं. आप रोकते कैसे फिर किसी भी ऑब्जेक्ट? अगर आपने एक बॉल को किक की है तो वो तो जाती रहती. वो रुकी इस वजह से थी बिकॉज देयर वाज सम फोर्स व्हिच एक्टेड अगेंस्ट इट्स मोशन. ऐसा है, इफ आई थ्रो एन ऑब्जेक्ट अपवर्ड, सो देयर इज अ फोर्स एक्टिंग डाउनवर्ड जिसको हम वेट के नाम से जानते हैं, एंड इट इज एक्टिंग ऑपोजिट टू द डायरेक्शन ऑफ द मोशन. अगर वो नहीं होती फोर्स, तो ऑब्जेक्ट को जिसको भी आप ऊपर भेज रहे हैं, आप थोड़े से किसी ऑब्जेक्ट को भेज रहे हैं, वो तो ऊपर जाता चला जाएगा, वो तो स्पेस तक पहुंच जाएगा, राइट. सो द फोर्स, it may be in the direction of the velocity, maybe in the direction of the motion, and if it is in the direction of the motion, so it means the motion is increasing, the velocity is increasing, right. And a force may be opposite to the direction of the motion as in the velocity, and when it happens, if it's in the it's opposite to the direction of the motion or the velocity, it means the velocity or the motion is actually decreasing, and we see the increase, decrease, the change in the direction of the motion all around. ये सिर्फ हमने एक सेम डायरेक्शन में इंक्रीज और डिक्रीज की बात की है. अभी तो डायरेक्शन चेंज की तो बात भी नहीं की हम लोगों ने, ठीक है ना. वी विल डिस्कस इन सर्टेन केसेस ओवर हियर, लेकिन बहुत डिटेल में नहीं. लेट्स से कंफ्यूज हो जाएंगे आप, छोड़ दें. ये वाली चीजें क्लियर हुई.
But acceleration for acceleration to be in the opposite direction wouldn't it depend on the magnitude of the force? Like
गुड,
if the force,
यही तो हमने बात लिखी थी. ये बात हमने यहाँ पे लिखी थी कि the acceleration, the acceleration solely depends upon the direction of the force wherever the force is. अच्छा देखिए, बार बार एक बात ना जो मुझे ऐसा ट्रिगर कर रहा है, हो सकता है आपको वो ट्रबल करिए. when we say acceleration, only one thing comes into our mind, that is increase in velocity. एंड जब डिक्रीज इन वेलोसिटी की बात करते हैं ना, तो वी हैव टू रेफर इट एज डिसेलरेशन. ऐसा ही है ना. तो
yeah.
लेट मी मेक इट सिंपल. अगर मैं बोलूं इफ द वेलोसिटी एंड द फोर्स आर इन द सेम डायरेक्शन, ऑब्जेक्ट वुड एक्सेलरेट, ऑब्जेक्ट वुड एक्सेलरेट. तो यहाँ पे एक्सेलरेट कर रहा है. एंड इफ द वेलोसिटी एंड द फोर्स आर इन द ऑपोजिट डायरेक्शन, द ऑब्जेक्ट वुड डिसेलरेट. एज सिंपल एज दैट, राइट. यस, इट्स डिसेलरेटिंग इन दीज टू केसेस. लेकिन हम क्या हमेशा डिसेलरेशन को नेगेटिव एक्सेलरेशन कह सकते हैं? नहीं कह सकते, बिकॉज यहाँ पे द एक्सेलरेशन इज नेगेटिव. नेगेटिव ड्यू टू द डायरेक्शन, नेगेटिव ड्यू टू द डायरेक्शन ओनली. ठीक है ना. लेट्स से इफ एन ऑब्जेक्ट इज फॉलोइंग डाउनवर्ड्स, फ्रीली डाउनवर्ड्स, इट्स फॉलोइंग फ्रीली डाउनवर्ड्स. तो देखें, अकॉर्डिंग टू द वेक्टर डायरेक्शन, सिंस द वेलोसिटी इज डाउनवर्ड्स तो नेगेटिव है, राइट. It is being acted upon by the gravitational force, which is negative. The weight itself, इसका weight जो है वो डाउनवर्ड एक्ट कर रहा था. तो जो नेगेटिव साइन है वो इसकी वेक्टर डायरेक्शन को रिप्रेजेंट कर रहा है. गेटिंग द पॉइंट?
Yeah.
तो थोड़ी बहुत कंफ्यूजन रहेगी, वो क्वेश्चन से सॉल्व होगी होपफुली. राइट? क्लियर हुआ पॉइंट यहाँ पे? So this is
Yeah.
acceleration is so acceleration could be acceleration is basically in general the change in the velocity, right? And the acceleration could be an increase, and it is referred as simply acceleration. Acceleration could be a decrease in velocity, and decrease in the velocity is referred as deceleration. बस छोटी सी बात ये समझनी है कि डिक्रीज इन वेलोसिटी को हम नेगेटिव एक्सेलरेशन नहीं कहेंगे हमेशा. इन सर्टेन केसेस वी विल, बट नॉट हमेशा. सही है? चले. Next move towards the next step. Next step was graphs, but since we don't have much time कि मैं ग्राफ को वन गो के अंदर करवाना चाह रहा था, so doesn't matter. We are moving towards the equations of motion. So we'll just discuss what equations of motions are, then we'll solve some of the questions और फिर हम ग्राफ की तरफ आ जाएंगे. तो सीक्वेंस यहाँ पे बहुत ज्यादा असर नहीं करेगी. What equations of motions are? देखिए, सिंस वी आर डन विद ऑल द फिजिकल क्वांटिटीज, हम सारी चीजें पढ़ चुके हुए हैं. तो जब एक फिजिकल क्वांटिटी हमने पढ़ी थी वेलोसिटी, तो वेलोसिटी का एक फॉर्मूला मैंने आपको लिखवाया था. हमने एक वेलोसिटी का फॉर्मूला लिखा था S/T, राइट? एंड इस S/T के लिए हमने कुछ कंडीशंस डिस्कस की थी, बहुत इंपॉर्टेंट कंडीशंस. तो कंडीशंस क्या थी? यूनिफॉर्म मोशन. एंड अगेन जैसे मैंने कहा कि अगर थोड़ा मोशन को डिकोड करना है, सो द बेस्ट वे टू डिकोड अ मोशन इज, तो यहाँ से मोशन को हटा करके आप वेलोसिटी लिखते हो. यूनिफॉर्म मोशन एज इन यूनिफॉर्म वेलोसिटी. यूनिफॉर्म वेलोसिटी का मतलब है कांस्टेंट वेलोसिटी, which means no acceleration. Acceleration जब नहीं होगी, if the object is moving with a constant magnitude of the velocity in any direction, be it positive, be it negative, अगर वो कांस्टेंट है, तब आप ये मैथमेटिकल एक्सप्रेशन यूज करेंगे. Now what if the object is accelerating? अब ऑब्जेक्ट एक्सेलरेट कर रहा है, तो मैं क्या करूंगा? तब तो ये फॉर्मूला वहां पे फिर वैलिड नहीं रहेगा. ठीक है ना? नाउ आई नीड सम न्यू मैथमेटिक्स. नाउ दोस न्यू मैथमेटिक्स, दैट न्यू मैथमेटिक्स is basically equations of motion. We have basically four equations through which हम अपना यूनिफॉर्म एक्सेलरेशन वाले मोशंस को सॉल्व करते हैं. तो इसलिए उनका नाम है इक्वेशंस ऑफ मोशंस. हम आज सिर्फ उन फोर से इंट्रोड्यूस हो रहे हैं और उनकी कंडीशंस पढ़ेंगे. एंड नेक्स्ट क्लास में फिर हम उनको क्वेश्चन बाय क्वेश्चन समझेंगे, सिंस इट वाज ऑलरेडी रिटन इन द प्रीवियस पेजेस, तो ये मैंने हटा दिया. द फर्स्ट इक्वेशन ऑफ मोशन इज v इज इक्वल्स टू u प्लस at. एंड फ्रॉम वेयर डिड इट केम फ्रॉम? हम एक्चुअली आज ये डिस्कस करने वाले हैं कि ये अचानक से तो नहीं आ गई है ना. नहीं, इनका कोई लिंक है, मैथमेटिकल लिंक है, तो मैथमेटिकल लिंक पढ़ रहे हैं. v is equals to u plus at कहाँ से आई है? इट इज नॉट अ न्यू इक्वेशन, जस्ट अ फेमिलियर इक्वेशन, बट अ रिफ्रेश्ड वर्जन. जैसे हमने एक फॉर्मूला पढ़ा अभी रिसेंटली, दैट वाज v माइनस u अपॉन t फॉर एक्सेलरेशन. हमने एक फॉर्मूला पढ़ा था. ठीक है? अब यहां से मैंने सिर्फ रीअरेंज करके v को सब्जेक्ट बना लिया. a द t मल्टीप्लाइड बाय a, एंड फिर अगेन v को अगर सब्जेक्ट बनाता हूं तो आई एम लेफ्ट विद u प्लस at. तो एक्सेलरेशन वाला जो फॉर्मूला था, आई जस्ट रीफ्रेज्ड इट, आई रीअरेंज्ड इट, v को सब्जेक्ट बनाया, एंड नाउ वी आर रेफरिंग इट एज फर्स्ट इक्वेशन ऑफ मोशन. ठीक है? सेकंड इक्वेशन ऑफ मोशन देखिए. नाउ व्हाट इज फर्स्ट इक्वेशन ऑफ मोशन टेल्स अबाउट? फर्स्ट इक्वेशन मोशन ये बता रही है, if an object was initially moving with a certain velocity, after it after it was already in a motion, but it accelerated afterwards for a certain time. So what would be a velocity व्हाट वुड बी द फाइनल वेलोसिटी आफ्टर एक्सेलरेटिंग फॉर सर्टेन टाइम टी, ठीक है ना। तो इसके लिए विल बी यूजिंग दिस फॉर्मूला, राइट। अच्छा, मैं ये सब बता के कंफ्यूज नहीं करूंगा कि फिर आपके जहन में लगेगा कि शायद ये स्पेसिफिकली इस्तेमाल होगा, नहीं स्पेसिफिकली इस्तेमाल नहीं होगा। चले, दूसरा इज v प्लस यू अपॉन टू बाई इंटू टी। कैसे आया ये फॉर्मूला इंटू बीइंग? देखें, वी स्टार्टेड विद अ बेसिक फॉर्मूला, हमने पढ़ा था v इज टू एस ओवर टी, राइट, जिसको मैं इस तरह भी लिख सकता हूं कि s इज इक्वल्स टू v मल्टीप्लाई बाई टी। लेकिन दिस v ओवर हेयर was constant, this v was constant over here. If v increases linearly, अगर वेलोसिटी लीनियरली इंक्रीज हो रही है तो फिर हम एवरेज वैल्यू कंसिडर करेंगे। एवरेज वैल्यू क्या होगी? एवरेज वैल्यू हो जाएगी आपके पास v प्लस यू अपॉन टू। वी जस्ट डिस्कस दिस इन द बिगिनिंग ऑफ द क्लास, सो आई कैन formulate this कि displacement covered during the linear increase or decrease of the velocity in a certain time could be written by this one. So यूनिफॉर्म वेलोसिटी वाला फॉर्मूला बन गया यूनिफॉर्म एक्सेलरेशन वाला फॉर्मूला, बट only in the case if the velocity increase or decrease uniformly. So what the formula tell? If the object, if the velocity of the object was increasing linearly, so this is the distance covered in a particular time during this linear increase or decrease, right? इसको अगर थोड़ा सा और अच्छे से समझना है तो यू कैन सी दैट कि अगर इफ द वेलोसिटी वाज लेट्स से कि स्टार्टेड फ्रॉम जीरो, ठीक है ना। अब इसी फॉर्मूले को हम इस तरह प्रूव करते हैं। इफ द इफ द लीनियर इंक्रीज इन द वेलोसिटी स्टार्टेड फ्रॉम रेस्ट, मतलब इनिशियल वेलोसिटी वाज जीरो, तो ये वेलोसिटी टाइम ग्राफ उसका इसी तरह बनेगा, a straight line graph, right? And how would I calculate displacement from a velocity time graph? That would be the area under the graph। ये वो इसकी कॉन्सेप्ट है, एरिया अंडर द वेलोसिटी टाइम ग्राफ। अगर नहीं आया तो कोई मसला नहीं है, आई एम जस्ट यहाँ पे रेफर कर रहा हूँ इस मेथड को। अगर नहीं आए, याद नहीं है, डजंट मैटर, हम आगे इसको बहुत डिटेल में पढ़ेंगे। सो एरिया अंडर दिस ग्राफ would be equal to the displacement. अब how would you find out the area of this graph? That would be half into base into height. Half is a constant, base is time, v is height. तो यहाँ पे अगर velocity को जीरो कर दूं तो this becomes the same formula as this one। velocity को यहाँ पे जीरो कर दो, you're left with half v t, this is the same। So this is how we got to know that this formula will be actually giving me the displacement covered in a specific time interval during a linear increase or decrease in the velocity। Got it? Now these two
Yeah.
are the most least used formulas, ठीक है ना। अब आ रहे हैं द मेन formulas जो कि बहुत ज्यादा इस्तेमाल होते हैं, ठीक है। So the one formula is s equals to ut plus half at square। You must be familiar with this formula. How usually we teachers quote this formula whenever we are doing homogeneity. So might be your teacher also use this as an equation for homogeneity. If not, so it doesn't matter. So this is the formula, and this is an equation how it came into being. We'll start with the basic formula of second equation of motion, v plus u upon 2 into t, right? And the first equation of motion was v is equals to u plus at, right? I'm going to replace or substitute the value of v in the second equation from the first equation, right? सेकेंड इक्वेशन का ये वाला फ्रेज, फर्स्ट इक्वेशन का ये वाला फ्रेज सेकेंड इक्वेशन के v की जगह सब्स्टिट्यूट किया मैंने, राइट। तो वो कुछ इस तरह का बन जाएगा। मैं पहले स्टेप के अंदर कलर्स को अलग अलग रख रहा हूँ ताकि याद रहे कि ये कौन सी इक्वेशन थी। एंड दिस वाज अ डिफरेंट इक्वेशन, ठीक है। तो ये पूरी इक्वेशन वही है, सिर्फ इसमें ये जो v है ना, इसकी जगह मैंने ये लिख दिया, राइट। नाउ आई एम गोना सिंप्लीफाई। सिंप्लीफाई कैसे कर रहा हूँ, देखें, इन यहाँ पे एक स्टेप बढ़ा रहा हूँ। दिस u एंड दिस u विल एड अप टू 2u प्लस 80, एंड बाहर भी एक t मल्टीप्लाई हो रहा है इससे। तो ये जो t है, जो बाहर मल्टीप्लाई हो रहा है, दिस वुड बी मल्टीप्लाइड बाय 80 ऑल्सो, एंड दिस वुड बी मल्टीप्लाइड बाय 2u ऑल्सो। सो एज अ रिजल्ट you will get 2ut plus at square. Now this denominator goes for both, so I can simply write it separately. I can write 2 over here and I can write 2 over here. These two cancel out and I am left with s, which was on the other side of the equation. Here is ut. This denominator wala 2 could be written as half and at square. So this is how the third equation of motion came into being. It is actually the mixture of first and second equation. Getting the point?
Yeah.
Yeah. Now coming to the fourth and final equation of motion, which is again a mixture of first and second equation. How? We'll start with the second equation again. Start with the second equation, like S is equals to V plus U upon 2 into T. And from the first equation, which was actually v is equals to u plus at, I am making a t as a subject over here. So if I make t as a subject, this would be v minus u divided by a, right? Now I'm going to substitute the t over here. So this equation would be like v plus u, which was already there, divided by 2. Then we'll get v minus u, which we get instead of a, and s is still there. I'm multiplying this 2 and a over here and moving it to the other side of the equation, which becomes 2as, and on this side we have v plus u and v minus u, which is, I remember, a mathematical identity. कौन सी वाली identity है? a square minus b square is basically equals to a plus b and a minus b. Do you recall it?
Yeah.
So this equation can be written as 2as is equals to v square minus u square, and this is where the fourth equation came from, right? Now, upon seeing these four equations, every student get confused. इतनी सारी equations, कौन सी equation को कहाँ use करना है? How would I know कौन सी equation को इस्तेमाल करना है? ऐसा ही है. You must be thinking the same. Now, look closely to the equations. The first equation, it has v, it has u, it has a, it has t, it does not have s, right?
Yeah.
The second equation of motion, which has v, u, s, t, does not have a. The third equation of motion has s, u, t, a, does not have v. The fourth equation of motion has v, u, 2, a, s, does not have t, right? So this is the key factor which from which I'm gonna realize कौन सी equation इस्तेमाल करनी है. For example, I've been given with a situation which does not involve displacement, neither given nor asked. So definitely I'll be solving with this formula, any formula that is displacement free, because displacement ना दी गई है ना उसने पूछी है. So I'm not concerned with the displacement of the object. If I'm not concerned with the displacement of the object, so I'm gonna use a displacement free equation, right? Now, for example, another equation, another situation is being given where acceleration is not our concern. मैं ये वाली इक्वेशन यूज करूंगा. कोई ऐसी सिचुएशन जो ज्यादातर आएगी वैसे आपके पास, जहां पर देर इज नो डिस्कशन ऑफ फाइनल वेलोसिटी, ना पूछी गई ना मांगी है, राइट, ना गिवन है. So I'll be using a formula that is free from final velocity. and any equation that is free from time, हम ये सिचुएशन यूज करेंगे. सो ऐसा नहीं है कि हर इक्वेशन का कोई अलग अलग यूज है ना. दे ऑल आर यूज फॉर वन सिंपल केस, एक्सेलरेशन. यूनिफॉर्म एक्सेलरेशन के लिए ये इक्वेशन लगेंगे. अब एज पर द डेटा एंड एज पर द सिचुएशन एंड एज पर द डिमांड ऑफ द इक्वेशन वी गोना सेलेक्ट इट, एंड दैट्स वेरी इजी. इतना मुश्किल नहीं है, थोड़ी सी प्रैक्टिस लगेगी. बस एक अहम चीज, वन वेरी इंपॉर्टेंट थिंग दैट वी मस्ट कवर टुडे, और फिर बाकी जो है वील बी कवरिंग इन द नेक्स्ट क्लास, वो ये है कि जस्ट लाइक वी डिस्कस अबाउट v इक्वल्स टू s ओवर t, उसकी वैलिडिटी को हमने पढ़ा था कि इट इज वैलिड ओनली फॉर अ यूनिफॉर्म वेलोसिटी. Even these formula, these equations of motion are valid for certain conditions, and these are the conditions जो कि वो पेपर 2 के अंदर पूछता भी है. इट आस्क कि ये फॉर्मूला, सर्टेन फॉर्मूला उसने आपको फॉर एग्जांपल दिया हुआ है, या फिर आपसे मांगा हुआ है, या फिर आपने यूज किया और उसने आपसे नेक्स्ट पार्ट में पूछेगा द फॉर्मूला यू यूज्ड अबव, what are the conditions, what are the conditions of this formula to be valid. So the first condition is the motion should be linear. Now what does linear motion means? Linear motion means any motion that is a straight line motion, forward, backward, upward, downward, even diagonal, but a straight line. If it's an oscillatory motion, like a pendulum wala oscillatory motion, if it's a circulatory motion, circular motion, so these formulas will no longer stand. We have different formulas for vibratory, oscillatory, or wave motion. We have different formulas for circular motion. We are gonna do cover the two motions, oscillatory and circular motion in our A2s. वो AS का part नहीं है हमारे पास, हम इंशाल्लाह A2s के अंदर करेंगे वो चीज. लेकिन जो स्ट्रेट लाइन मोशन है हम उसे ट्रांसलेटरी मोशन भी कहते हैं. Actually, the motion you have been learning since your grade 9, a object traveling from one position to another, simply that motion is referred as straight line motion, linear motion, translatory motion. ठीक है. Second and the most important one, uniform acceleration. Uniform acceleration as in कि जो acceleration की value है ना वो constant है. Any value, be it 2, 3, 4, 100, 1000, but the value is constant. The acceleration is not changing. If the acceleration changes, so these equations will no longer support you mathematically. फिर ये mathematical support नहीं दे पाएंगी. उसके लिए हमें we need a different mathematics. Do you have mathematics in your AS level?
No,
No. Did you
no.
have advanced?
No, I have biochem physics.
Oh, so you don't have any idea about differentiation and integration.
Um, I have done a little bit of differentiation in
You've heard about it.
IGCSE.
You have an idea.
Yes, yes.
Actually, differentiation and integration are used to solve non-linear motion in which the acceleration is not constant, and we won't be doing it neither in our A2s, right? So these formulas are valid for linear motion and uniform acceleration. That means that the rate of velocity by which it is increasing or decreasing is a constant value, right? So I hope you get all the points.
Yeah.
चलिए, I'll update you. I'll give you the all the slides जो कि आज हमने cover किए. If you have missed anything to copy down, तो आप आराम से कर लीजिएगा. Today we discussed. We started from the average speed and average velocity. We did a question upon average speed. Then we discussed acceleration, the direction of the force and velocity and acceleration very briefly. And then we discussed the acceleration of motion, the equation of motion. और बहुत thoroughly discuss किए हैं. There would be several classes इसकी practice के लिए, several classes, ठीक है? Because this is the chapter which requires a lot of practice, तो वो हम साथ ही साथ करेंगे. ठीक है. In the upcoming classes, since we have started equations of motion, so in upcoming classes we'll be doing some basic questions just to understand equations of motion. उसके बाद we'll moving towards the graphs, and then we'll return towards the entire question style, graphs and equations of motion. ठीक है. So meet you in the next class Wednesday, same timing. Any question?
No.
Okay. Allah Hafiz.
Allah Hafiz, have a good day.